Okay, I'm making another video. This is a pretty good one. I'm charging this battery down here. It's a good battery. It's not flat. Whoa. And I'm charging it through the run cap phase of my favorite rotovertor motor. It runs on 30 milliamps at idle at 120 volts. Has ceramic bearings and 1/3 horsepower Marathon brand, connected WYE, and it's in the rotovertor mode where it runs on single phase, and you have a run cap between L2 and L3. So over here I have a voltage doubler circuit. See all these diodes? I actually paralleled them to make sure it can handle a lot of amps. This is for something else I did years ago, pulled it out of the box. There's 4 caps in parallel at 270 UF each, so this is equal to 1080 UF caps right here. And this is not a full-wave bridge rectifier. It's called a voltage doubler. It's a voltage doubler circuit. I think there's 6 total caps. When you start voltage doubling and tripling and quadrupling, this is supposed to be the most efficient, just a doubler. So anyways, that's what's on there to change the AC from the run cap phase into DC. That's what I did here with this voltage doubler circuit. That feeds this battery at this voltage, which is pretty good, about what you want. And here's what's really good, is my motor's only drawing 40 milliamps, so it only went up 10 milliamps, hooking all this stuff up off the run cap phase. Now, it's in series, 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 to the L3 line. When I tried it in parallel to the run cap phase, it made the draw go way up and everything vibrated. It was no good. This way works really good. And I'm charging up this battery at, what would that be, 12 watts input, 10 times 120.01. So it's 10 milliamps times 120 volts. It went up. Now watch this. If I disconnect the battery out of the circuit, you hear some vibration, and look how much the draw goes up. Connect the battery in the circuit. Look at the draw. Isn't that nice? So I'm going to put it on pause. I want to see how many amps. I'm going to put an ammeter going into the battery and see what it says. I'm curious. Okay, just 1 minute. Okay, the amperage going in. I disconnect it for a bit, and now I plug it in. And 600 milliamp setting. I think the capacitor fills up and the capacitor drains down. Going into the battery is what's going on. But it does show some amps going in. I'll do it again. Watch this. I disconnect the battery. And you know, now the draw goes up. Now when I connect the battery, it'll show a lot of amps. This is in 600 milliamp setting. And it dies down. It takes a while for it to die down. So I'm guessing I should have a different value caps here and something. I don't know. The diodes are a lot more hefty than need to be. But anyways, I'm sure this battery's getting charged. At what rate is unknown. But I'm very happy it doesn't make the draw of the motor go up except a little bit. Okay, I'm going to do another experiment. I'm going to plug this battery into my motor generator over here and run it. See what happens now. Just to report, I plugged this positive green wire to the positive and my finger touched this at the same time as this and I got a big shock. And I shouldn't get any big shock because it's just a 12 volt battery there being fed about 15 volts, but I did. So just to let you know, if anybody does this, look out, there's something DC psychic getting through there or something, I don't know, but I got a pretty big shock. Okay, I'm going to go on. Hope it doesn't blow out my MOSFET circuit here. I have a voltage regulator on it. We'll see. So I'm going to plug this battery into that, see what happens.